So choosing a line of regression, you can do two different regression lines depending on the variable, and you can approximate those variables depending on which one you want to focus on. So far we've been doing the y on x regression line, but you can go ahead and switch those if you want to. So the format that they use is not the normal y equals mx plus b. They actually put the y-intercept first, and then they put the slope and variable last. So if we're doing a y equals, normally this would say mx plus b, but instead they're going to put the b first, and then, excuse me, the m last. Okay, and then vice versa for the x and y here. Okay, so in our next example 6, we have two scores marked out of 10 for a class of students in English and TOK. So we have two different data sets that are independent of one another, but they have the same student. So what you can do is use one graph for the two sets of data. So we're going to go ahead and do a regression line for each of the sets of data, depending on which one we're focusing on. So in this case, when you're doing it on a graphing calculator, it has it on the stat plot. You do your normal one, which is the y on x, and then you do the reverse version of that, and it's like the 4 more down on the stat plot there. They're super easy to find, a little bit harder to do with the Desmos graphing calculator, so that's what I'm going to show you there. I have everything already typed in. I went ahead, I put this one, I have my 2 rows here, and remember when you do your plots, there needs to be a subscript with an underscore, and then the tilde for your plots there. So on this one, we have a slope of 0.763, which is the red line on this one. And then we have the y-intercept of 1.92. So when you write them together, it's going to be first. Your y-intercept is going to be first, and then your slope and your x variable is going to be second. So this is the normal one to do it. The only thing that's different is the fact that these two are flipped. So that's the way we've normally been doing it. So if you want to do it the other way, where the x is on y, all you have to do is switch your two variables. So instead of y1 being first, the x1 is going to be first. So then it gives you a new line, right? Gives you a new slope, gives you a new y-intercept. Okay, and same thing, you're going to write it backwards. So the y-intercept is going to go first, your slope is going to go second with the y in the back. Okay, and that one happens to be the black line there. Okay, so here it gives you it here. We have the 0.139 and the 0.02, 0.902, and then we have the y. So we have two different equations, and now we can answer pretty much anything that we want to know about either the English class or the TOK class, and that's what they're going to ask you. It says, find the predicted TOK score to the nearest whole number for a student who scores in the 9 in English. So the English class is your X, so you're going to be using this first formula. You're going to plug a 9 in and then get an answer. In this case, because everything's whole numbers, when they plug in the 9, they get a 9 out as well. Okay, same thing, read part E. Find the predicted English score to the nearest whole number for a student who scores 8 in TOK. The 8 in TOK is the y, so the 8 goes in to the second equation into y, and then you're able to calculate the predicted English score, which is rounded to a 7. So yeah, it's just switching up the two ways on how to do it. But the idea is still the same. Plug in your information, find your linear regression, and answer some questions about the scenario.